Hello everyone. Today let's solve the problem number 739, daily temperatures. So you can just go through the problem and try to understand the problem with the help of example. So I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given an array of integers temperatures. You can clearly see here we are given an array of integers, this one temperatures, where each value represents the daily temperature. Here each value represents the daily temperature. So we need to return an array answer. We need to return an array answer where each element at index I indicates the number of days one must wait after the ith day to encounter a warmer temperature. So we have to return the number that one must wait after the ith day to encounter a warmer temperature. In this case, we can clearly see 73, 74. So here 73, this guy has to wait for 1 day because the warmer day, the next here, this one consists of the larger number than 73. Nothing but the temperature is more. So he has to wait for 1 day, right? Here, so it is given here 1. So that's what the same goes with all the numbers. Let's discuss this one later. Just for the sake of understanding, I said that one. So one must wait after the ith day to encounter a warmer temperature. So if no warmer day exists, then we have to set the iterated value of the answer, nothing but output, to the 0. Here no warmer day is present. Let's consider the last one here, 73. There is no, we are not considering the future day, right? So 73 is the last day. There is no warmer, next warmer day or the future day. So we are considering 0 here, just for the understanding purpose, right? So first, what we'll do, let's discuss the examples, then let's discuss the approach as well as the edge case, and then write the code and discuss the complexity, right? So here, I'll just come to this example. First example, let me come to the first example. Here, let's consider this example here. So we have 73 here. Let's consider the next warmer day. Here 73. 73, we have to consider 74, right? So it will be 1 here. It will take 1 day, next day itself. So it will be 1. Let's consider 74 now. 74, we have the greater number. This is nothing but the 75. So this will also be 1. Next, this will also be 1. Next, let's consider 75 here. 75, for 75, the next day is 71, which is lesser. So we will ignore this one. Let's move to the next one, which is 69. So 69 is also lesser than 75. So we'll move to the next one. So 72 is also lesser than 75. So we'll move to the next one, 76. So it takes 4 days for the next warmer day for the 75, right? 1, 2, 3, 4. So we are displaying 4 here, right? So let's consider 71 now. We are considering 71 now. We have already considered 73, 74, 75, 71. So 69 is lesser than 75, 71. 72 is greater than 71. Nothing but it takes here 2 days, right? So the output we are displaying here is 2. Same goes with 69. 69, next day itself we have 72. So we are displaying 1 here, right? We are displaying 1 here. Next, let's consider for 72. Next day itself we have 76. So again we are displaying 1 here, right? So next, let's consider 76 here. For 76, the next day is 73, which 73 is lesser than 76. So we are displaying 0 here. So we don't have the further number, right? So next, let's consider for 73. 73, we don't have any future days at all, or we don't have further number to consider at all here in the array. So we'll be displaying 0 here. I hope now you have got the idea, right? So same goes with example 2 and example 3 as well. Please do check for example 2 and example 3. You will understand it better. So let's discuss the approach and let's discuss all the edge cases first. So here, let's discuss the approach quickly. So first thing we have to remember here is we are going with the monotonic stack here. We'll be making use of the monotonic stack for this particular problem. So let's see the approach step by step. So first thing is we have to understand the problem, right? So for each day, look ahead to find the next warmer day. If no such day exists, then we will set the value. We have to set the value to the 0, right? So if a next warmer day is present, then we are setting the value to the 1. If no warmer days present to the particular day, then we will be setting the value to the 0, right? And this is well suited for the monotonic decreasing stack. So I'll just write here MDS. So this problem is well suited for the monotonic decreasing stack because we can efficiently track the temperatures and the indices to compute the difference, right? So next, let's go with how the stack mainly works. Main logic, or let's go with the main logic here. So we have to maintain a stack to store the indices of days. Let's make use of, we are making use of stack, or we'll be making use of the stack to store the indices of days, right? We'll be making use of the stack. So next thing is, for the current day, compare its temperature with the temperature of days stored in the stack. So for current day, what we will do? We will compare its temperature with the temperature of the days stored in stacks, with temperature stored in stack, temperature of days stored in the stack. So this is what we will be doing. So the next step here is, if the current temperature is warmer, then calculate the difference in days. We have to calculate the difference in days, right? So that's what we saw in example. If current day is warmer, then we are calculating the difference in days. That's what we saw in example. Difference in days, and then we will update the result array and remove the index from stack. So after doing this, what we will do? We will update the result array. This is simple, right? We'll update the result array, and finally we will remove the index from the stack. We will remove the index from stack. So I hope this is clear. Next, we will push the current index into the stack and repeat the same step for all the days. What we will do? Finally, we will push the current index. We have to push the current index, right? So first we'll push the current index into the stack, and we'll push the current index to the stack, and finally we will repeat for all days. We saw this one with the example initially. So now I hope the approach is completely clear. This is the approach that we will be going with. First, we are maintaining a stack to store the indices of the days here, and this one logic, let's come from here. So we'll be making use of the monotonic stack. This one is fine. So we are maintaining a stack to store the indices of the days. And the second thing is, for the current day, we are comparing the temperature with the temperature of days that is stored in the stack, this one. And if the current temperature is warmer, we are calculating the difference in days, right? We are calculating the difference in days, and we are updating this one. You can clearly see we are updating the result array, and finally we are removing the index from the stack. And the final step is, we are pushing the current index into the stack and repeating the same thing after all the days. I hope the approach is completely clear. Next, let's see all the edge cases and then write the code. Here, the first edge case that we are going with here is no warmer day. When I say no warmer day, I'll just consider the input here 80, 80, 80. So we don't have any warmer day here, right? So the output will be 0, 0, 0. Just give me a second here. No way, this is not working. So yeah, sorry. here, so all the temperatures are same here. So no warmer day exists here, resulting in the output 0, 0, 0. Why? Because if we compare this one, we don't have the larger number compared to this. We don't have the larger number compared to here. Here we don't have the next number at all. So the output will be 0 here. This is for the no warmer day. This is the first step, and this is the first edge case. The second edge case that we'll be going here, going with here is this one, single element. So input, let me give here 90. So here when I give the input 90, we have only the single day, and that single day has no future day at all, right? So the result will be obviously 0 here. This is for the single element, edge case single element. So next, let's move on with the third edge case. This will be strictly for the strictly for the decreasing temperature. Strictly decreasing temperature. When I say strictly decreasing temperature, we will go with 100, 90, 80, 70. Here you can clearly see, while I say strictly decreasing temperature, the output will be 0. Why? Here we don't have the this one at all, right? The number which is greater than this number at all. So here no day has the warmer future day. So all the values will be here 0, 0, 0. So we have to mention this one like this, right? So here it will be 0, 0, 0. Here also I forgot, I think. This one will be basically the output will be 0 for this one. Yeah, this one 000 here. This is fine. This one here, we don't have the next warmer day. Here for this one also we don't have the next warmer day. This one next, no next warmer day. We don't have the number at all, right? So this is for the strictly decreasing temperature, right? This is the third edge case. Let's move on with the fourth edge case, nothing but the strictly increasing temperature. So the input I'll be considering here is 30, 40, 50 and 60 here. This is fine. So here each day has the next day as warmer. You can clearly see the number is greater here, 40 is greater, and we'll be displaying 1 for this. And 40 has the next warmer day, which is greater actually, 50. We'll be displaying 1 here, and 50 has the next warmer day, nothing but 60 here. We'll be displaying 1. Here we don't have any value for this, so we'll be displaying 0. The output will be 111, 0. So each day has the next day as warmer day, so resulting in 111, 0 here. So this is for strictly increasing temperature. So we saw with strictly decreasing temperature and strictly increasing temperature. So let's go with the final edge case, nothing but mixed pattern. So this is the example one. I don't have to explain this one. I have already explained this one. 73, 74, 75, 71, 60, 72, 76, 73. That's what we have. I have already explained this one, right? So the output will be, the output will be, the output will be 1142 11 0 0. I don't have to explain this one. I have already explained this one. So here the warmer days exist for some days, but not all, resulting in the output this one. You can just check this one. I have already explained this one. This is just the same example one they have given in the problem, right? So I'll just come here. This is for mixed pattern basically, right? So the first edge case that we saw here is for the this one, no warmer day. Second one was for the single element. Third one was for the strictly decreasing temperature. Fourth one was for strictly increasing temperature. The final one is for the mixed pattern, right? So I hope all the edge cases are clear. Next, let's write the code. While writing the code, I'll explain the code while writing the code itself, right? Let's start writing the code. Here, the first step will be, we'll be initializing an array of 0 to store the results. So I'll just give here, let result here. Let me consider array of temperatures. This one, let me copy this one. Length of the temperatures, right? This is fine. Then let's fill this one initially with zeros. So this is fine. We have to initialize an empty stack. We have to store the indices as well, right? For that one, we need to have the empty stack. So let's initialize an empty stack to store the indices. This is simple. Okay, this is fine. So the next step here is iteration. The second step, main step will be iteration. We have to loop through the each day's temperature. So I'll just come here. This is simple. Let me consider here current day, initialize with 0 and current day. Let me copy this current day for now. Current day less than temperatures, length of the temperatures, and finally we are incrementing the current day. This is fine. So within the loop, what we have to do? We have to check if the stack is not empty and the current temperature is greater than the temperature at the index stored in the stack. That's what we had discussed in the approach as well. This is simple. I'll just consider simple while loop here. If length of the stack and temperatures here within this one, let me give stack, the final element in the stack, nothing but the length of the stack minus 1 here. This is fair, is less than the temperatures of the current day. Let me copy this one. Let me give here. Let me copy this one. Sorry. Let me copy this one. Temperatures of the current day within the array, right? So let me paste it over here. Current day. So we are checking if the stack is not empty. That is the reason we have considered stack.length here. This one, right? Array. Why this? Yeah, this one. We are checking whether the stack is empty, and also we are checking the current temperature is greater than. If current temperature is greater than the temperature at the index that is stored in the stack, then we will pop the last index from the stack. So how can we write that? So we have to pop the last index from the stack, right? So I'll just consider one variable name previous day. So I'll just give here stack.pop. I hope this is clear. Then after popping the last index from the stack, we have to calculate the difference between the current day and the previous day, right? So this will be a result of, let me copy this one, previous day, that is difference between the current day and the previous day, right? So let me copy this one, current day minus here previous day. This is fine. And the next step here is we have to push the current day onto the stack as well. For this, let me consider stack.push of current day. So here, this is fine. Finally, after pushing the current day onto the stack, I'll just come out of this one, and finally we have to return the result array. So result array, we have considered the variable result here. Let me give here return result. So this is fine. Let me format this one once. Let me run the code. So here you can clearly see the sample test cases are getting passed, and let me hit the submit now. Can clearly see all the test cases are getting passed, and this one, the code works absolutely fine here. So let's quickly discuss the time complexity and the space complexity here. So the approach that we went with here is this one, monotonic stack. You can clearly see here, and the overall time complexity here would be big of n. Why the overall time complexity here is big of n? Because each element is pushed and popped from the stack at most once here, where you can clearly see here, right? Each element is pushed and popped from the stack at most once, resulting in the linear time. So the overall time complexity would be big O of n, and the space complexity would be big O of n as well. Why? The stack can hold at most n indices in the worst case. We know this one. Stack can hold at most n indices in the worst case, right? So the space complexity here would be big O of n as well. So overall time complexity and the space complexity for this one would be big O of n. So yeah, this is it. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.